We are taking R.D. Sharma solution, class 12, chapter 9, continuity. Exercise is 9.1. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. Now x is equal to 2, at x equals to 2, the function is continuous. So when you go left or right, this function we have to use, which is when the x is not equal to 2. So when x is equal to 2, this is k. Now how to do this? This expression holds the key. That is, you need to know how to divide the algebraic expression, how to factorize it. So whatever limit we compute, we have to equate it with k. So limit x tends to 2 fx, which is the function which we are talking about, is equal to f2, which is k in this case, right? Let us solve it. So we have x cube plus x squared minus 16x plus 20 and divided by this numerator. Since we have x minus 2 whole square in the denominator, it is not x minus 2 into x minus 3 in the denominator. So we know that, or we can deduce that x equals to, we can check for the numerator. Okay. For example, denominator x minus 2 into x minus 3 will check for 2 and 3 both. But here we have the number which is x equals 2. Let us check it. So in this expression, I am placing 2. I am replacing x by 2. So what do we get? 2 cube plus 2 squared minus 16 into 2 plus 20. This is 8 plus 4 minus 32 plus 20. 20 plus 12 is 32. 32 minus 32 is 0. Okay. So x equals 2 is that basically x minus 2 is a factor. So how can we write x minus, this first expression, the numerator expression? When we have x minus 2, what will be the remaining part? There are different methods you can do. Those who are able to do it by themselves, it is very good, because that is the whole key of this question. But I will divide this expression by x minus 2 to get what is the remaining factor. So x cube plus x square minus 16x plus 20. X minus 2 we are dividing. So this is x square multiplied by x square, so that you get x cube. So you multiply this by, this is simple division of algebraic expression. So we need x cube, so x square multiplication, you get x cube minus 2x square. Okay, now subtract these, change the sign and subtract, means subtracting means change of sign. So you get 3x square minus 16x plus 20. Now we need 3x square, so multiply this by 3x, so you get 3x square and minus 3 to the 6x. So this also you can change the sign, because you're subtracting 6 minus 16 is minus 10x and you have plus 20, right? So now we need 10x, actually negative 10x, so minus 10 multiply, minus 10x and minus minus is plus 20. So now you can cancel these two out because you are subtracting, it will be 0. So what is the next factor? The factors of x cube plus x square minus 16x plus 20 is x minus 2 and x square plus 3x minus 10. So this factor we can easily find out. We know that 5 2s are 10 and 5 and 2, if they are subtracted, you will get a 3. So x square plus 3x minus 10 it is. So I'll just change it. It is not plus 10. It is minus 10. So let me just change it now. So I'm not doing it right now. I'll just change it, okay, because it is minus 10. So there is a slight mistake. Let me just cancel this out. Yes, this is minus 10. Okay, so let us do like this. Let us do like this. X square, it is negative 10. X square plus 5x minus 2x minus 10. So x plus 5 minus 2x plus 5. So you will get x minus 2 into x plus 5. So now you have two factors here, x plus 5 and x minus 2. Now replace x square plus 3x minus 10 by this x plus 5 into x minus 2. So numerator we have x minus 2, and x plus 5. In the denominator you have already x minus 2 into x minus 2, that is x minus 2 whole square. So you just cancel this out. So only remaining thing is x plus 5. Now let us apply the limit x tends to 2 in x plus 5. So applying 2 here, 2 plus 5 is 7. So the limit of this function is 7. Limit is 7, right? Now equate it with k. So k is equal to 7. This is your answer. So let me tell you again, this is the main key factor of factorizing it. Find the values of a and b so that the function f given by fx, this, is continuous at x equals 3 and x equals 5. So what do we do here? We have let me just make an arbitrary graph. It is not the graph of this function because basically x plus b is a straight line. But I'm just for understanding, in this type of question, for example here 3 and 5. So we have to check the continuity at 3 and 5 both. We have been checking for one value, but now we'll check it for 2. So you have to do 2 iteration, one for 3, one for 5. Okay. So how do we do this? We'll start with x equals 3. So this is a point 3, x equals 3. And we move back because x is less than or equal to 3 here. It is a constant. So it will always remain a constant. It doesn't have any x. So putting any value for the limit or not putting won't affect. But the right hand side, if you go above 3, it is ax plus 5. So we'll take the left hand limit, right hand limit, we'll equate it. So left hand limit, right hand limit. What is this? X equals 3 minus h will put in the left hand limit. X equals 3 plus h will put in right hand limit. But we'll only target the right hand side because we already know there is a constant here. So where do you put x? There is no x with the constant. So it will always remain as 1. On the right hand side, it is ax plus 5. In place of x, replace it by 3 plus h. Is it ax plus 5? No, it is ax plus b. Oh, slight mistake here. I did a mistake. I am correcting it. It is ax plus b. Please remember, we are putting x equals 3 plus h in place of x. But this is not ax plus 5. It is ax plus b. So there is a slight correction. I hope you will be, doing that. Okay, now this a, you can multiply this 3a plus ah plus b. Now just apply the limit here. H tends to 0. When you apply the limit, it will be 3a plus b because ah will be 0. Now you have to equate this now. Left hand limit and right hand limit you have to equate. So 3a plus b is equal to 1. This is what you have to do, right? So this is your first equation from x equals 3. Now since the continuity has been already declared, it is continuous at x equals 3 and x equals 5. So we'll do it for x equals 5. Left hand limit, right hand limit. So if you go back, it will be ax plus 5. If you move forward, ax plus b again. I'm sorry for this b, I'm again and again saying 5. So ax plus b, and right hand side we have there's no value, only constant is there. There is no x, so just you can place it as 7. Okay, so you have left hand side as ax plus b. So by 5 minus h on the left hand side, 5 plus h on the right hand side. So we will put this a in place of x. We are going to replace it by 5 minus h. So a 5 minus h plus b. So 5a or a5 minus ah plus b, will apply limit here. This h tends to 0. This ah will be 0. So 5a plus b it will be. So what it will be? It will be equal to 7. 5a plus b is equal to 7. So 3a plus b equals 1. 5a plus b equals 7. So 3a plus b equals 1. Just cancel this out. You have a 2a. 2a is equal to, this is 6. So a will be equal to 3. Okay. Now just put it here. 3 into 3 plus b equals 1. b is equal to 1 minus 3009. It is going to be minus 8, negative 8. A is 3, B is negative 8. This is how you solve this type of question. I hope you'll be able to solve these kind of questions now, because plenty of questions are coming like this. Okay, we have to check because we have to show here. It is not given already. We have to show that this function f is continuous at x equals 1. So x equals 1, when we move a bit backward, it will be x square by 2 we are going to use. Just behind 1, you can say. A step back from 1. So left hand limit will use x square by 2, and 1 minus h we are going to use here. On right hand side we are going to use 2x square minus 3x plus 3 by 2, and in this case we are going to put x as 1 plus h. Okay, 2x square minus 3x plus 3 by 2. So x equals 1 minus h here, x equals 1 plus h here. Okay, so h tends to 0 here, h tends to 0. So 1 minus h whole square divided by 2. You can open it also. If you don't want to open h, you can place 0 here only, because when you open it using square a minus b whole square, it is going to come h, wherever h comes it will be 0 anyways. Okay, 1 by 2 it will come. I have placed h as 0 here. Here again 2, 1 plus h whole square minus 3 into 1 plus h plus 3 by 2 twice of now you can place h 0. Similarly, the same way we did just now, you can replace this h by 0. So limit h tends to 0. This is 2, h is 0, so 2 1 into 1 square is 1 only. It will be actually 2 minus 3 plus 3 by 2, because eventually everything is 1. We have this leverage here because it is 1 plus h and 1 minus h, that is why. So 2 minus 3 plus 3 by 2, 2 plus 3 by 2 is 2 to the 4 plus 3 by 2, that is 7 by 2, and subtract it with 3, so 7 minus 6 divided by 2, it is going to be half. Now you see, this is also half, this is also half, right? Okay, now is this done? No. Left hand limit and right hand limit are equal. This is fine, but still we have one step still remaining, which is the value of the function at x equals 1. LHL and RHL are equal, but we have to check it for the function at x equals 1. So f1. What is the value of the function at 1? It is x square by 2. Replace x by 1. 1 square by 2 is 1 by 2 only. Now all the three values are equal. That is why this function is continuous at x equals 1. Discuss the continuity of the function fx at the indicated points. These are the, see, these 39.1 etc. These all questions are having modulus in it. So whenever you get the modulus or the absolute value, we are going to check this function for 0 and 1. But modulus value is positive x when it is x greater than 0. It is going to be negative x when x is less than 0. Right? So this is very clear. If you are very clear about this concept, all these modulus questions, because in competitive exams most of the questions are related to this modulus. So we have to check at x equal to 0 one time, and then later we'll check for x equals 1. So x equals 0. So x will put 0 minus h, x will put as 0 plus h for left hand limit and right hand limit respectively. Just put this LHL and RHL. In place of x, just replace it by 0 minus h. So 0 minus h, this is 0 minus h plus. In place of x, just put 0 minus h. Minus 1 is already there. Okay, coming to right hand limit. Now place 0 plus h in place of x. Mod 0 plus h and plus in place of x 0 plus h minus 1. Okay, what is this? 0 minus h is minus h. Minus h is h only. Modulus of minus h is h. Here minus h minus 1. What you can do is you can take minus common. You can say h plus 1. And when the modulus is removed, it will be positive. So plus h plus 1. Basically it is 2h plus 1. But we'll just apply the limit. On this side, right hand limit, 0 plus h is h only. So mod h, it is h only, plus 0 plus h minus 1. So when we open this modulus, you can apply limit here also, or you can replace it by h minus 1 when you open this. Because when you apply this h as limit here on this case only, it will be negative 1 will be positive 1 when it comes out of the modulus. So now apply the limit. 2h plus 1 is 1. Here h is 0, so it will be 1. So left hand limit and right hand limit, they both are coming as same. Okay, at x equals to 0. Now you can put 0 at that point also, because you need to have the value of the function at x equal to 0 also coming as 1, and you can just verify it. The second case is x equals 1. Same thing we are going to do. On the LHL we'll put 1 minus h, RHL will put 1 plus h, right? So in this mod x plus mod x minus 1, in place of x, replace it by 1 minus h. So 1 minus h plus x, so 1 minus h minus 1. And here you'll replace it by 1 plus h. So mod 1 plus h plus mod 1 plus h minus 1. So now this 1 gets cancelled. 1 minus h is 1 minus h only. This is get cancelled. Minus h will be positive h. Here 1 plus h, let it be like this. And 1 gets cancelled. You get mod of h. So now just apply the limit. H is 0. Mod 1 is 1 only. So 1 plus h. H 0. Mod 1 is 1 only. I am applying limit h tends to 0 both the sides. So mod 1 is 1 only, 1 plus h. Now apply the limit h tends to 0. It will be left hand side, it is going to be 1, right hand side also 1. So in both the cases, at x equals 0, x equals 1, both the cases LHL equals RHL. So the limits are equal. Okay, so we can very well say that this is continuous, because we need to check at x equals 1 in this also. So let me just give you the final verdict, because we have to check for x equals 0. So mod 0 plus mod 0 minus 1, what do you get? You get mod 0 is 0 only, because f0 we have to also find out, f1 also we have to find out. So this is going to be mod 0 is 0, 0 minus is minus 1, and mod of minus 1 is 1. So these all three are matching. Then we say it is continuous. Here also we'll check. What we'll do, in place of x, we'll replace it by 1. So mod 1 plus mod 1 minus 1, 1 minus 1, and this mod 1 is 1 plus 1 minus 1 is 0. So 1 it is. So this one is equivalent to this one, and this is also similar to this one. So all these three are matching. Then only LHL and RHL won't work. You have to also show that the value of the function at this point is also same as LHL and RHL. I hope you got the idea. Okay. This question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.